So section 4.7 is on law of sines and law of cosines. You did this in geometry class. There may have been a few examples where they didn't get very difficult in geometry and they're going to get a little more difficult in this class, but for the most part, stuff is the same, okay? So from geometry, if you remember, we had these situations. We had angle, angle, side, angle, and then side, side, angle. We had theorems that used both of these. None of the theorems for this one worked, okay? But for law of sines and law of cosines, this can now be used. Now this is, we're not proving two triangles congruent, but we're trying to find missing parts of missing triangles, okay? So angle, angle, side is when you're given an angle, and a side. Angle, side, angle is when you're given an angle, a side, and an angle. And then side, side, angle, which is a bad word in math if you flip it around, and angle, side, side. Now, I don't write it that way, but this is how I'm always going to draw it. I'm always going to draw the angle and the side and then the side, because every single time we do it, if you face it that same direction, you'll be able to go through and follow the same process to figure out your missing parts and pieces, okay? These two are pretty straightforward. This is going to give us something called our ambiguous case, because you can possibly have two different triangles. So for angle, side, side cases, these are your possibilities, okay? If you know it's a right triangle, you actually don't need to use any of this. If it's a right triangle, you can use sine, cosine, or tangent. Sometimes they don't tell you that it's a right triangle. They're going to give you two of the sides and one of the acute angles, and so you find out later that it's a right triangle, okay? But if it's right or obtuse, when you draw it like this, the side opposite, if that is smaller than the side adjacent, there's not going to be any triangles, okay? If the side opposite is bigger than the side adjacent, then you're going to have one triangle. And again, that's if this given angle is right or obtuse. If this given angle is acute, you have all four of these possibilities, okay? And if you take the time to draw it this way and look at it, when we go through and do our examples, you'll see you don't necessarily have to have this chart with you at all times. You can go through and you can go through this process and you'll be able to figure out if there's 0, 1, or 2 triangles without having to go through and say, okay, is this the case? Is this the case? This is handy to have, but you don't need this chart, okay? The other two from geometry is when we had side, 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 and side, angle, side. Side, side, side is when you're given all three sides of a triangle. Side, angle, side is when you're given two sides and their included angle. If these are the situations that you're given, you're going to use law of cosines, okay? Now remember, when you draw a triangle in geometry class, okay, the angles are labeled with capital letters A, B, and C. And it doesn't matter if it's a right triangle or not right triangle. We use A, B, and C for right triangles all the time, but this applies to any triangle. The angles are going to be named with capital letters. The side opposite them are the corresponding lowercase letters. So angle A, side A. Angle B, side B. Angle C, side C.